Hello and welcome one and all. Today we embark on the journey to integrate stream processing to a data lake. We have covered the stream processing using Postgres, Debezium, and Kafka. With this tech stack, we stream data to a Kafka topic from Postgres. We have covered the data lake with the following tech stack. We use a S3 compatible storage for data, Hive Metastore, and Trino to create tables and query this data. Today we'll integrate the data stream from Kafka to this data lake setup. We'll store the Kafka topic data to the data lake and create a table using the Hive Metastore and query it with Trino. We have already covered how to integrate Kafka data to an OLAP database in the shape of ClickHouse. We perform the real-time analysis with this data stream using Streamlit. If you're interested, I will leave the link for that video in the description below. Just to give you an overview, we have both of these stacks running on Docker. If you need to set up these components, then watch the data streaming and the data lake series. As usual, I'll leave the link below, and you can also find them on the channel's website in their proper space. We will assume you have the setup complete and in working order. Today we will build on this setup. Few updates before we dive in. I have updated the MinIO image in the data lake setup, therefore the interface may look different. You can get the updated Docker file from the repo and update the data lake stack. In addition, I have added the iceberg properties to the Hive Metastore in case we want to use the iceberg tables. This is our stack in Docker. The data lake is built on MinIO, Trino is our query engine, and this is backed by Hive Metastore that is utilizing MariaDB. In the MinIO, we have created a new bucket called Kafka bucket. It is empty at the moment. We can browse the directories under this bucket. However, there are no objects present yet. This is our Trino setup. We have the MinIO schema. This is where we'll create the Hive tables. In addition, we have the iceberg schema present here as well. We can create an iceberg table utilizing the Hive table. Just to jog your memory, this is our Python script that inserts data to Kafka. For testing purpose, we are reading this data with a Python consumer. We have a couple of messages flowing through from this topic. Okay, now to the integration. This is where we will integrate Kafka stream to S3. First of all, we need the S3 connector. This allows us to export data from a Kafka topic to an S3 object, either in Avro or JSON format. We can download it from the Confluent website. This zip file contains the required jar files under the lib folder. We'll need to copy these to the Debezium container. We can extract these files and load them during the container build, or if we have the container already running, then we can open the container using VS Code. This requires the Remote Explorer extension. Now we can browse the Docker containers. We'll open the Debezium Docker container in a new window. Using this, we can access the container's file system. We navigate to the Kafka directory. From the file menu, we can open any of the folders present in this container. So from here, we choose the Kafka folder. The connector files are under the connect directory. Here you'll notice all the connectors defined in this environment. We create a new folder for the S3, and now we can drag all the jar files that are part of the S3 connector. With all the jar files selected, I will drop them on the newly created S3 folder in the Debezium container. This action will copy all the S3 connector jars to the S3 connector folder. There are a number of jars, so it may take a few seconds. I have already created an S3 folder, so I'll remove this one. Under the S3 folder, we also copy the Debezium jars that we can grab from one of the existing connectors. We need the Debezium API and the core jar. Okay, our connector setup is complete. Next, we need the S3 sync connector definition. We'll grab this from the MinIO blog. We'll use the following settings. You'll have to update the MinIO details for your setup. We'll create an S3 connector that'll persist Kafka's data to MinIO. So we'll use Postman to create this connector. This is the connector definition. It is a S3 sync connector from Confluent. We have provided it with the Kafka topic and an S3 bucket. This requires the MinIO detail so it can connect and persist data. We define the key and the value converter setting, as well as the format and the storage. From the dropdown, we switch the call to post and send this payload to the Debezium API. Our connector is created. Now if we switch back to get call, we should see this new connector defined in the system. The best way to confirm that your connector is created is by looking at the Debezium containers log. It logs all the detail here, so if there are any errors, you can view them here and troubleshoot any issues with the connector. Back in our S3 bucket, we notice a new folder. This has our Kafka topic, and this directory contains JSON file that contains the actual data. Our Kafka to S3 integration is complete, and we are successfully writing Kafka data to S3. Now we can open the Trino query engine and create Hive tables utilizing the S3 data. This will allow us to query the JSON files using SQL. So let's go ahead and create a new schema in the MinIO database. This schema points to our Kafka bucket. Once we execute this script, our schema is created and we can expand and view the schema. We will create a table in the Kafka schema. We define the columns with the expected data type and provide the external location that points to the MinIO folder location where the data is stored. Also, this requires the format, which is JSON. We execute the query to create this table. We can validate the table with a select query. We want to make sure this table actually contains the Kafka data. Okay, this is a success. We have our topics data in this table. Using this Hive table, we can insert data into an Iceberg table. This is an optional step. Iceberg doesn't support external location, therefore we can use the Hive table and insert data from it to an Iceberg table. And once this is complete, we can query the Iceberg table to confirm it contains data. Iceberg data is stored in the warehouse bucket in MinIO. We can view the sales table. If you need additional information about Iceberg, then watch the Data Lakehouse videos. They go in depth on Iceberg. One thing of note, the Trino connector does not support regular deletes. You need to delete the partition in order to delete data from Iceberg table. Okay, let's test our pipeline. We'll go ahead and insert a few more records in the stream table to see them flow through our data pipeline. We insert the following sales order numbers in the source table. So once this is complete, we can head to our Trino engine and query the Hive table and see these order numbers flow through to our table. This pipeline is successfully streaming data to Kafka, which is persisted to S3, and our Hive table is picking up the new data in real time. So our data stream and data lake integration is complete. We can successfully query and analyze Kafka stream data using SQL that is persisted to S3. In the next session, we'll explore Apache Spark. We'll read and process data with PySpark. Spark has a native Iceberg integration, so we can directly read data from Kafka and persist it to S3 using PySpark. This enables full Iceberg functionality. Therefore, we can perform various DML operations on the Iceberg tables. So this is end-to-end integration of the data stream pipeline with Data Lake. We have persisted the stream data to S3 and made it available for analysis via Trino, and we can plug in any BI tool that supports Trino to further analyze this data. This is all for now. I hope you enjoyed the session. Like, share, and subscribe. Take care, and I'll see you in the next video.